What do you think of when you imagine a space colony? You probably envisage a city of bubble domes, extending off into a red horizon, or a sleek steel metropolis. What you probably don't expect is something like Swindon's Hole, here in the Mendips. The first citizens of Mars will be cave explorers. So why don't we want to live on the surface? Here are 2 chocolate chip cookies that I've baked to go caving. Out of the oven, they were both the same temperature, but as you can see, they've since started to cool down. The larger cookie has been able to retain more of its heat. Inside, it's still gooey. These cookies are just like Earth and Mars. When the solar system formed, they were both molten, but over the eons, they've since cooled down. The much larger Earth still has its gooey, molten core, which gives us a protective magnetic field. Mars's core cooled faster, just like the smaller cookie. With no molten core to produce a magnetic field, Mars is defenseless against the nasties of space. Solar flares and galactic cosmic rays can pass through your spacesuit and permanently damage cells and DNA. In order to avoid this radiation, we need some form of shielding, such as in the form of several meters of rock. The best way to get that is to head underground. I'll see you in a minute. Since we took our first close-up picture of the planet in the 1960s, we've known that Mars has a network of tunnels extending beneath the surface. Unlike here in the Mendips, these caves weren't formed by water, but instead were carved out by rivers of lava. Fortunately, with the core freezing over, it's unlikely that we're going to be roasted alive. In order to make Mars our new home, we just need to transform a small section of cave into living space. For that, we need 2 things. First, we need to produce an atmosphere, and then we need to make sure this atmosphere doesn't escape. Making an atmosphere isn't super difficult. Mars hasn't had liquid water in millions of years, but around the equatorial regions, there are permanent deposits of ice. That's useful as a potential drinking supply, but with a little electricity, we can make something even better. These 2 wires are connected to a DC power supply. They are then submerged into this tank of water. As you can see, the electricity rips apart the water molecules into 2 constituent gases. The negative cathode is producing hydrogen gas and the positive anode, oxygen. As you can see, there is 2 times more hydrogen than oxygen, which makes sense given that the chemical formula for water is H2O. It's been about an hour, and in that time, we've been able to produce 3 balloons of gas. We'll be able to use our oxygen gas to make a breathable atmosphere for our Mars explorers. By combining our gases back together, we can produce something just as useful, rocket fuel. All we need is a spark. Keeping our atmosphere in place is actually quite simple. This is a limestone rock, such as you'd find in Swindon's Hole. As you can see, cracks along the surface make it easy for air to escape. Fortunately, our Martian caves don't have that problem. Igneous rock is much more impervious, which means it will do a better job at keeping in our atmosphere. Because Mars's caves were formed by lava, the insides already have a pretty good seal. All we need to do is patch up a few gaps and put a big airlock at the entrance. One of the biggest questions in science is, are we alone? Finding life on Mars would be the defining moment of space exploration. As we've been exploring the cave, I've noticed something quite interesting. On the surface, it was freezing. Well, this is England, so fair enough. However, here in the cave, it's actually quite warm. That's because this huge mass of rock helps to regulate the flow of heat, keeping the cave at around the same temperature year-round. At the equator, Mars's surface temperatures can fluctuate from a pleasant 20 degrees in the day to a freezing -100 degrees at night. The more consistent temperatures below ground make it much easier for life to survive. If we were to head down much deeper, such as in a mine, we'd find the temperature would actually start to increase. That's because of the heat inside the Earth's core. Although Mars's core is much cooler than the Earth's, this same effect still holds true. We might find lakes of liquid water if we head down deep enough into Mars's caves. Many stalactites, such as these, play host to whole ecosystems of bacteria, not seen anywhere else. There are some species that can eat the rock itself. We think that Martian caves might support a form of life that eats hydrogen gas and produces methane. Orbiting satellites have even spotted this methane accumulating around cave exit points, changing in concentration in step with the seasons. Could this gas be being produced by an unknown geological process, or is it really life? We just don't know yet. We need to explore the Martian caves to find out.
The question is, do we really need to send people down, or could robots do just as good a job? While NASA's rovers have been doing some fantastic science and driverless cars are getting better and better, there are some situations, such as in a cave, that humans are just very well adapted. As you can see, this is a pretty extreme environment.
On the physical side of things, humans are a jack of all trades. We can go from walking to crawling to climbing, and in this case, even swimming. This is one of NASA's limbed excursion mechanical utility robots, a lemur for short. Its many dexterous limbs help make it the world's first rock climbing robot. Despite this, it still has one major problem. It needs to be controlled by a human. Remote control isn't really an option when your operator is on a different planet, with a time delay of up to 24 minutes in either direction. Not only that, but any signal that you're trying to send is going to be blocked by hundreds of meters of rock. Going fully autonomous is a possibility, but it's taken years to get a car that drives itself. All that has to do is drive along a flat surface between two white lines.
While robots might one day be able to deal with this environment, that eventuality is long off. For now, route picking, problem solving, and getting out of a tight squeeze are all things that humans can do far better than any machine.
Martian caves are the perfect place for science, in a location ideal for human colonisation. But to explore this alien world, we first need to conquer the caves here on Earth.